I'm not going to try to prove that Buddhism is in some way scientific, but rather compare the two as different forms of knowledge. I think one has to be very careful of making claims for forms of ancient philosophy that some are more in accord with the spirit of science than others. For in so many ways, science is such a new thing in the world. And I often find that people who make claims for various religions or philosophies of the ancient world as being scientific actually don't know very much about science. So I think we should start in this sort of discussion asking, what is science? First of all, science is a method of description. If we have a form of this kind, a rather wiggly form, as I've sometimes said, the natural world is full of wiggly forms. And science, in dealing with the natural world, is an attempt to describe them exactly. If we describe this particular form poetically, as distinct from exactly, we might say, well, it's like a flame dancing above the fire, burning gas, or something of that kind. But the interest of science is to describe these forms very precisely indeed. And to do so, it employs a method which is fundamentally like this: to superimpose over the form some very simple, regular pattern in terms of which the form can be described. And what we see here is a system of squares which can be described accurately because they can be numbered up and down. And if we were, for example, to fill in the light gray area, the squares over which the form passes, we should get a rather rough but still approximate formal equivalent of the original figure. But you notice in the top left-hand corner of the screen that where the squares are drawn much more finely, you get a greater approximation to the original figure. In other words, the whole method of scientific description is one of, shall we say, putting things in boxes. Basically, this is the act of classification, of representing the complex forms of the world in terms of simpler, regular forms that we can understand, regular forms that we can count, measure, classify, and so on. And in this way, we get a well-controlled description of physical reality. So you could say that in a way, science is the art of definition, of getting things down, as we say, in black and white, of assimilating the unknown, the irregular, and the wayward to patterns that are known, regular, and controlled. And basically, this is really the whole operation of that distinctively human activity that we call thought. Because thought is fundamentally classification, and so also science is classification. If you read older works of science, works of, say, natural history and zoology, you will see that the primary concern of the scientist was to classify the various species of nature, the various types of butterflies and insects, the various forms of rocks, the various varieties of plants, and to get them all into classes, like animal, vegetable, mineral, and all their innumerable subdivisions. And so, thought fundamentally asks of classes. Is a given natural phenomenon in that class, or is it not in it? The question is always, as we say slangily, is we is or is we ain't? And this method of classification is not only basic to thought, but in a way it's basic to the operation of the human nervous system. For of each one of the neurons that compose our nervous system, it can be said that it has only two states: a state corresponding to yes and a state corresponding to no, like an electric current is either on or off. And in the same way that, for example, the television camera scans a given scene, such as my face, and sends impulses along a wire to the transmitter and then to your set. These impulses are fundamentally of a yes or no character. And the structure of the screen at which you are looking is something like that grid structure which I showed you a moment ago, spread over the black flame. And it reinterprets the picture in terms of ever so many little units of on or off, yes or no. So in the same way, the great computer machines which scientists have built to give mechanical equivalents of the human mind use, in most cases, what we call binary arithmetic. That is to say, a number system in which there are simply two numbers, 1 and 2, corresponding approximately to the same duality of yes and no upon which all thought is based, and which is also the basis of classification. When we put, in other words, when we put phenomena into mental boxes, when we class them, the fundamental question is it in this box or is it not in this box? And this is the basic principle of science, which it elaborates in the most marvelously complex ways. And I think we might think about some of these more complex forms. The scientist, as I said, does not simply consider the world in terms of such very simple patterns as the grid or the set of squares drawn over a form which he wants to describe accurately. To go to an opposite extreme, the task of the mathematician, who is fundamental to all science, is really to think up complex patterns. And the pure mathematician doesn't bother his head particularly as to whether the patterns in algebra or geometry or arithmetic with which he's concerned bear any resemblance to events in the real world. For example, we would say that in the real world we live in a space, a physical space, in which there are only three dimensions. There's the dimension of height, of width, and then in perspective we can represent the dimension of depth. And we feel that in the real world, in the physical space with which we're familiar, we can only have three right angles drawn about a point. The right angle between height and width, the right angle between depth and height, and the right angle between depth and width. But, of course, the mathematician can, in theory, think of an infinite number of right angles round this point in a kind of imaginary space that we cannot visualize with our senses. And he can say, for instance, that a line drawn this way is also at right angles to all the other dimensions, and go on and on and on, inventing an apparently fantastic space which has infinitely many dimensions. Now, it may so turn out that this speculation, this construction of a fantastic pattern, does have some actual application to nature. And the mathematical equations which are concerned with spaces of infinitely many dimensions are actually applicable to fluctuations in prices and things of that kind. But this was an entirely unexpected application. So the fundamental task of science is to invent patterns and see in applied science whether these patterns enable us to comprehend the behavior of the physical world. There's another sense in which patterns may be used to explain things. Supposing I draw such a figure as this, and ask the question, what is it? Now, there are various ways of explaining this figure and making what appears to be, at the moment, a sort of nonsensical abstraction, the very sort of thing we run across in the natural world, of making some sense of it. Now, supposing I say that is a drawing of a tree trunk with lopped off branches on it. This immediately, in your mind, makes sense of the picture because it has related it to something with which you're familiar. In another sense, it has classified it. It has given an intelligible pattern to these lines which I scratched out on the board. But supposing we offer another explanation of it and say, it's a bear climbing a tree. Of course, the bear is hidden behind the tree. This gives you an entirely different picture of the same original drawing. And so, in the same way, when the scientist explains various natural phenomena, let's say we see a partial eclipse of the sun. Now, if you are a member of a culture which firmly believes that eclipses of the sun are the result of the sun being eaten up by a dragon, you will see something here corresponding to what you see in this drawing when you say, oh, it's a bear climbing a tree from behind. You will have in your mind's eye a highly complex and elaborate version of what's going on here, something in fact like this. There will be the dragon eating up the sun. Now, you won't perhaps actually visualize that dragon in the same way that when I tell you that this is a bear climbing a tree, you will almost, see the bear behind it. Here he is. Almost in your mind's eye, you see that bear. And almost in your mind's eye, if you really believe that a partial eclipse of the sun is caused by a dragon, you will believe that you see the dragon. But on the other hand, if the scientist explains it more simply and says a partial eclipse of the sun is simply caused by the moon crossing the sun, you will have a simple picture like that in your mind's eye. So these are the ways in which the scientist is giving an account of the world. He is assimilating things that we don't know, patterns that we don't understand, to patterns that we do understand. And so the question arises further in exploring what is the function of science, to ask, why do we want to do that? Why do we want to be able to describe the world in terms and in patterns that we can understand? And surely the answer is that if we can interpret the unknown in terms of the known, if we can describe what is going on in the world in regular patterns, we can predict what things are going to do next. In other words, if a pattern is regular, it is regular not only in shape, say, it will also be regular in rhythm. We time the apparent rising of the sun, and we find that it rises daily in a regular rhythm. And so every new day we feel we can bet on the sun following the same rhythm since it has done so for so long. And so then further, what is the point of predicting future events? Obviously the point of predicting what is going to happen is that it enables us to control what is going to happen, to adapt our own actions accordingly, and therefore to establish what we call technical control over our physical environment. And in this way then, you could say that the purpose of science is to control both our own nature and physical nature, in order that the human race may survive as comfortably as possible in its natural surroundings. And you will see that that involves, in other words, a constant superimposition of human ideas of order upon the apparent disorder which we first find when we look at the natural world. In other words, when a baby is born, or when a blind person first acquires the gift of sight through a surgical operation, what they see with their eyes is a chaos. A mature blind person who has never seen but is enabled to see by an operation, at first of all finds the experience of sight extremely confusing. He can't make any sense out of it at all. And he has to learn it. In other words, he has to interpret what he doesn't know, the objects of vision, in terms of what he does know, the sense of touch. He has to realize, for example, that the four corners of a table which he sees out there are related in a square pattern. And he has to understand how what he sees, the unknown, is related to what he has felt with his eyes closed through his fingertips, the known. And in this way, then, the whole task of applied science is, as it were, to assimilate the world of knowledge to the patterns of human order in rather the same way that when we eat, we assimilate dead bulls and dead vegetables and eggs and all that kind of thing. We absorb them in and we assimilate them to the physical organization of the human body. Knowledge is, in other words, a form of eating. Just for the two processes are equally of assimilation. And therefore, the extension of man's control over nature might metaphorically be described as a mental eating up of the universe. And as a result of this process, the organization of human life, its systems of communication and systems of control, are extended more and more and more in just the same way, for example, that by assimilating the minerals out of the soil and the rays out of the sunlight, a plant like a fern grows and grows and grows and extends its form. And in this way, its organization prevails. Now then, you see, if you take this task of what we call the conquest of nature, the task of making order victorious over chaos or randomness, if you take this seriously, you will look upon it as warfare. And you will firmly believe that the most urgent thing that there possibly can be is to make order prevail over randomness, to make good prevail over evil, to make life prevail over death. And we find that when we are in a contest of this kind, a serious warfare game of this kind, and we take it seriously, we are involved in it in a very deep and bitter sense. Now, the difference of Buddhism from science as a form of knowledge is that in Buddhism it would be said that this view of things, this view of the task of life as making order triumph over disorder, leaves something out. You remember right at the beginning I made some importance of a Sanskrit word which is fundamental in Buddhism, avidya. Avidya, which meant a means non, vidya, knowing. Non-knowing or ignorance, or better, ignorance. Ignorance, in other words, leaving something out of account. And I want to use a familiar illustration to show in what way we ignore. You see here a figure which is apparently, as you look at it, two faces in profile about to kiss each other. Now, if we draw back a little from those two faces, we can see on the white area in between them the form of a cup. But the interesting thing about this is that as you look at it, you will either be able to see the form of the cup or the form of the two faces in profile, as it were, about to kiss each other. You can alternate them between them very rapidly, but you will not be able to see them both that way at the same time. In other words, either the white must be the background and the black the figure on the ground, or else the black must be the background and the white cup showing up on it. And so in this way, we are unable to see, really, we can think it. After a while, we can get accustomed to the idea that the figure and the ground, the black and the white, are mutually necessary to each other. In that figure that I showed you, you could say both the cup with the stem and the two faces are there. But our ideas about them, our concepts, are mutually exclusive, and we cannot see them both at the same time. And in the same way, in this figure that I drew, we either see the sawn-off stumps or the bear claws. It's difficult to see this figure both ways at the same time. And so, also, just as we see one and not the other, so we identify ourselves. After all, when you're looking at the white figure in that illustration, which is the cup, you, as it were, identify with the cup. When you look at the two faces, you identify with the profile. So in the same way, when we experience the world around us, we identify with the subject, the knower. We don't identify with what we see. But as a matter of fact, if there is nothing seen, there is no experience of a seer. If there is no seer, there is no experience of anything seen. They both go together in the same way as the black and the white. And this idea that the yes and the no, the black and the white, the inside of a class, say we draw a square as representing fundamentally the idea of class. I can't have a square which doesn't have both inside and outside. They go together. And in Buddhism, this going together is called shunya. Although this is often translated void, it means that the inside of the square cannot exist, is void without the outside, the subject without the object, the black without the white. This, of course, is represented in this fundamental Chinese figure of the yang, or the positive principle, and the yin, or the negative principle, like two fishes, constantly circulating, going round and round and round and round in the alternations of life. Now, the question is, are these two fishes involved in a fight? Is the white one eating up the black one, and the black one trying to eat up the white one? If that is the situation, then of course life is fundamentally nothing but a grim contest. If this one up here is the good fellow and this one is the bad fellow, if this is order and this is chaos, then a fight goes on between them. That's largely the way in which our technology has interpreted man's situation as against nature. This is man, the white, the good fellow. This is nature, the dark, the bad fellow, and the white one has got to eat him up. But what happens if the white fish succeeds in eating up the dark fish? The white fish disappears as well as the dark one, because the white one is only there in relation to the dark. So then, if these two fishes, as it were, wake up, if this one wakes up and this one wakes up, which is called awakening in Buddhism, they realize they're one. In other words, they go together. They're inseparable from each other. And this realization is that experience, which is called in Zen Satori, or in Buddhism Bodhi, awakening. This sudden dawning on our consciousness that life is not really a contest to make yes triumph over no, to make the positive triumph over the negative. The two sides go together. And then one sees, in this strange way, that underlying all that is negative in the world, all that is in a way painful and evil, there is a kind of necessity to it. It goes with the good
It is necessary for the good. Disorder is necessary for the manifestation of order, just as you must have, say, a black background to show up a light figure. And then when one sees that, a profound transformation takes place in one's attitude to the world. That is to say, instead of looking upon life as a contest, it becomes a dance, it becomes a game. One doesn't withdraw from it, one doesn't stop living, but one goes into the game so that these revolving fishes are no longer trying to eat each other, but they're just going around dancing, having the biggest fun in the world. So then, must we have fixed in our minds the idea that all the forms and patterns of nature are simply methods of attack or defense, that they're devices for camouflage, that they're simply lures for sexual attraction or other utilitarian purposes? Or can we see in them a dance, a joyous cosmology?